Hey there! Welcome to Neural Networks by Nikita Silaparasetty. This is part 1 of the series, which will just be a basic introduction to neural networks. Now before we begin, I just want to clarify two things. First, these lessons will be short and simple, mainly so that if you are new to neural networks and deep learning, you'll be able to understand easily. Second, these lessons are made with the assumption that you have a prior knowledge of the basics of machine learning and Python libraries. If you do not, I would advise you to brush up on that first before continuing. I have provided some useful links in the description box for this. Alright, let's begin. Now, what are neural networks? A neural network is basically a replication of the human brain. Our human brain helps us to learn, and as we learn, we become better at doing things, right? In the same way, a neural network is like a brain for a machine. With the help of neural networks, machines are able to learn, and thus they become much more efficient at performing certain tasks. The human brain consists of neurons, while neural networks are made up of perceptrons, which are modeled after neurons. Now let us compare a neuron and a perceptron. Looking at the diagrams, we can see that although there are obvious differences between them, the basic structure is similar for both. Theoretically, we have two main differences. First, a neuron is a biological model, while a perceptron is a mathematical model. This is explained more clearly in the second point. The second point states that a neuron receives information in the form of electrical signals. Now this is something for a biology class, so I won't go into the details of it. A perceptron, however, receives information in the form of numbers. This means that all the inputs, the calculations, and the outputs will be numerical. Let us now see the components of a perceptron. I will go back to the image in just a second, but first, let's see what a perceptron is comprised of. A perceptron has inputs, weights and a bias, a net input function, an activation function, and finally, an output. Now coming back to the diagram, we can see that this perceptron has 3 inputs. A perceptron can actually have any number of inputs, but for simplicity's sake, I have shown only 3 here. We then have the 2 parameters, which are the weights and the bias. The number of weights will be equal to the number of inputs, but there will always be only one bias. I have put them together as a single category just for ease of understanding. Next, we have the net input function, which is an equation that performs calculations on the inputs and the 2 parameters. The output of this is passed on to the activation function, which then gives us the final output. Now, one very important thing to note here is that it's universally accepted to refer to perceptrons as neurons. Thus, we will be following that as well. Great, so let's come to the components of a neural network. A neural network has a minimum of 3 layers. It will always have one input layer, one output layer, and one or more hidden layers. The input and output layers will only have numerical values, while the hidden layers contain the neurons of the neural network. This is also where all the computation happens. In this case, we have considered a shallow neural network, which is the most basic type of neural network, as it has only one hidden layer. Any neural network that contains more than one hidden layer is known as a deep neural network. Thus, we see how neural networks are important in the field of deep learning. We will study this in detail in later lessons. Alright, so that's it for this video. If you have any questions or helpful suggestions, please do leave a comment. And if this video was helpful for you, please leave a like and share it with others who may benefit from it as well. And do subscribe for more videos. You can also press the little bell icon to be notified as soon as I upload a new video. Okay then, see you in the next video. Bye-bye.